Above this tier is the quantitative software engineers, the data scientists, the machine. Hey guys, what's up? It's Louder here, coming back with another episode. Math for programmers and how much you actually need. And make sure to stay till the end where I tell you how much math I actually learned and how much I actually use. So let's jump into it. Now, as a programmer, yes, you do need mathematics, but I consider there to be 3 tiers of how much math you actually use. Let's go ahead and dive into the first one. The first kind is arithmetic. Arithmetic style mathematics essentially means the 5 operators. You have addition, subtraction, multiplication, division, and division with remainder. These make up the basic operators that most programming languages contain. That's how you operate on integers, floats, decimals, different kinds of math-based data types. So once you go into that, that is used for everything from basic calculators to even e-commerce. What do I mean by e-commerce? Say you're making a back-end shopping cart, right? So on the shopping cart, you're going to have your list, your items, and their numeric. So you're going to have an apple for $5, and this is an expensive apple. It's going to be an apple for $5, and you're going to buy 2 of them. Right there, all you need is multiplication, and then you're going to need addition to sum up every single item on your list, and then multiply that by the tax for the total with tax. Sounds simple? It is. That's going to be the basic level and the first level. That's where most beginners are going to be. That's where most beginners will need to be just for a little while. Within that level, most people can stay there. You have a lot of web developers that outside of JavaScript and a few different kinds of functions and very basic mathematics, they don't go beyond that. UI, UX, web designers. There's a lot of tech and a lot of programmers and a lot of software engineers and that little big umbrella where that's okay. Arithmetic is more than enough. Then you begin to go into the second level. That's where you should be hitting the subscribe button, the little bell notification, and the like icon. So what do I mean by the second level? The second level essentially means, and this is where most software engineers will lie, it's when you understand basic algorithms. You begin to go from calculus 1 to discrete mathematics and foundations of mathematics. You don't need to go into calculus 3 or multivariate statistics. The majority of what you do will go and become what is known as just logical thinking. So what do I mean? Okay, you're a software engineer and you're doing an algorithm. Well, you have to know the asymptotic runtime, whether that is logarithmic, linear, exponential, constant. That analysis is generally much more a middle tier software engineer, someone who's comfortable with mathematics. Now, let's take this a step further. Let's say you need to understand different kinds of combinations. You have 1,000 possibilities that can be 1,000 ways. Well, that's no longer basic arithmetic, although it sounds like it. It begins to be the second tier. You have to be able to understand and think in logical, algorithmic ways. Discrete mathematics goes over numbering systems such as binary, octal, decimal, hexadecimal. The number system that most people are used to is the decimal system. And what I mean by the decimal system, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 is actually 1 and 0. When you go into binary, although we have the translated version, all you have is 1s and 0s. 3 becomes 1, 1, 4 becomes 1, 0, 0, and so on and so forth. You have hexadecimal. You not only use 0 through 9, but A, B, C, D, E, F. So I know that seems a little bit odd, but that is part of what the middle tier is. You begin to use much more mathematics than when you started, and this goes also between not only software engineering and programming, but computer science as a whole. In general, the middle tier is a combination of computer scientists and self-taught programmers who also went beyond the basic knowledge and learned computer science topics. Now, above this tier is the quantitative software engineers, the data scientists, the machine learning. And when I say machine learning and AI, I don't mean the people who know libraries like TensorFlow. I've messed with TensorFlow. Not TensorFlow, my bad. TensorFlow. Sure, you can go ahead and pick up a library and you can work with it, but what I mean is you're programming the library. You understand what linear matrices are. You understand how to optimize the mathematical activation functions that go into AI and machine learning. You actually understand what they do. Now, that's not to say that middle tier or the second level of software engineering programmers can't do this stuff. It's just the highest level begins to be more of a mathematician who's also a software engineer. You begin going into multivariate statistics and statistical theory and Bayesian and things that are much more complex than you would at just a middle tier. This goes beyond analysis of algorithms. This goes trying to create modeling applications, trying to create things that are generally not used unless you're specifically doing that kind of work. Who would you consider this to be? This would be the quant traders. Have you ever heard of those? The quantitative software engineers that were trying to predict the market. These are the actuarial engineers, the people who are working with the insurances, but also creating applications to use the actuarial models to either make decisions or throw out estimates or things like that. Between the middle tier and the high tier, there is some overlap. Now, between the second and the third level, there is kind of a blend. If you're trying to make a game engine, then you're going to run into people who have some knowledge of the upper tier and have quite a bit of good knowledge of the middle tier. And you require physics components, you require equations and things like that to be able to build out a sophisticated physics engine, a game engine. If you go into graphics, then you need to know geometric equations. You need to understand three-dimensional space, X, Y, and Z coordinates. Programming itself is a sister of mathematics. It is the applying of mathematics and creating instructions. At the end of the day, programming is just creating instructions for the computer. What instructions you create really depends on what application or what you're doing. Can you make an extremely complicated web application that takes AI and tries to do all this really crazy stuff where you need to make a fancy and super complicated mathematical model? Yes, you can. That is what cart recommendations are. That is every time you go to, let's say, Amazon, and they're like, hey, you may be interested in this. Well, they took a bunch of points based off your profile and were able to make a recommendation based off some mathematical model they have. Is this entry-level programming? Far from. So I told you if you stay till the end, I would tell you how much math I did and what I currently use in my day-to-day job as a software engineer. I took algebra, trigonometry, calculus 1, calculus 2, discrete mathematics, foundations of mathematics, and I even started linear algebra, but I withdrew from the class early on because I didn't need it to graduate and I wasn't too excited about getting a math minor because I was already overloaded. That was the basic thing I took. Those math were part of my required curriculum. That means that I needed them to graduate, but I did enjoy them. And going back, I wish I could have completed out linear algebra. I wish I could have taken multivariate statistics. I wish I could have actually taken differential equations. I love mathematics, and that's just part of what my personality and who I am lends itself to be. So what do I use in my day-to-day job? I use no more than a bit of asymptotic notation and analysis and basic arithmetic. There have been moments, and I'll be honest, there have been moments where I used a bit more. I had to do Bezier curves. Bezier curves, I'm probably mispronouncing that, takes a lot of complicated mathematics and tries to create a curve between 2 points. And that curve could be used for a variety of reasons. In my case, it was to create a graphical item on a map. So there you go. Different kinds of mathematics lend themselves to different applications. Now, I have done some machine learning and artificial intelligence work when I was back in university, and I didn't completely understand the math I was working with, but I was able to make a mathematical model that worked. And when I say worked, I mean probably 75 to 85%. I don't remember off the top of my head at the moment, but it did work for the assignment and I passed the class with good scores. The types of mathematics you will need completely depend on the application, its features, and what you're developing and what you're programming, as well as the skill level of the software engineer. Can you easily create a very simple app with very basic programming knowledge? Yes, you can. Can you create an extremely complicated system that takes mathematical models, AI, and this other really cool buzzwords and this other really cool tech? Yes, you can. It's all part of a spectrum of knowledge. You go from knowing very little to knowing a lot, and it completely comes down to where you want to be as a software engineer. So do you need math? Yes, you do. How much depends entirely on what your goals are. So guys, I hope you liked the video. If you did, please leave a like, comment, and subscribe. If you didn't, please leave a dislike and tell me what you hated. I always look to improve my channel. I want to help you guys, especially those of you that are wanting to become a software engineer. There's a lot of uncertainty or things that you're not aware of. So guys, it's been fun. I'm logging off. I'll see you in the next one.